Hello, and welcome to my lab report. I'm Robert Pegg, and today we will be discussing Lab 1, which is about charge. For this lab, I had to perform an experiment where I would charge pieces of tape with the goal of deducing the electrical force from the tape, as well as exploring Coulomb's law. After completing the experiment, I had to use GlowScript to create a program that models the circumstances of the experiment. From there, I will compare the model and my observations. Initially, I had difficulties charging the tape and measuring its effect, but after some jury-rigging of materials, I was able to deduce the charge of the tape, which I found to be positive. This lab was particularly important because it required me to use Coulomb's law in an experimental setting, which I had not done before, helping cement it in my mind. The structure of the rest of this lab report is going to be as so. First, I will talk about setting up the lab. Then I will discuss the properties of charged matter. From there, I will show the results of the lab. Based on these results, I will present my computational model and compare it with reality. After that, I will answer some thought-provoking questions, and then lastly, some final thoughts and conclusions. To perform the experiment and determine the charge of the tape, I needed the following materials. In the next few slides, there will be videos demonstrating the use of these objects. The video on the slide shows how I charge the tape by ripping one strip off of another. Using the measurements below, these charged strips, and a ruler, I was able to determine the effect of one strip on another. The process for this will be detailed further in a later slide. The first step for determining the charge was to identify whether it is positive or negative. To do this, I used the pen test. A plastic pen run through hair results in an object with negative charge. By placing the pen next to the tape and observing that it is attracted, we can determine that the tape must have a positive charge because Coulomb's law says opposite charges attract. However, we also know charged objects are attracted to neutral objects, and so to eliminate the possibility of the tape being neutral, I placed my hand by the tape and saw the tape was attracted. Because my hand is neutral, we now know for certain that the tape has a positive charge. To determine the magnitude of the charge, I applied Newton's second law and Coulomb's law in conjunction. By holding a charged piece of tape under another one, such as the one suspended in the photo, I can observe that the tape will float. Because the tape is motionless while floating, the electric force must counteract the other force, gravity. Then, by recording the distance between the charges as measured by the ruler behind the tape, I can do algebra to determine the magnitude of the charge of the piece of tape, because we can assume the two tapes will have the same charge, since the same process was used to charge both. There were two other assumptions made too, since I ignored air resistance and treated the tape as a point charge instead of a charged strip. These assumptions, as well as the difficulty of using the ruler to measure the R value, all are sources of error. My first step in creating the model was to put in constants such as K and G. Then I created the objects that will represent the two pieces of tape. Tape B represents the floating tape, and tape A is the one I held below tape B. From there, by inputting the values necessary for calculating the force of gravity and electric force, I can obtain values for these forces and represent them as arrows, sort of like a force-body diagram. When calculating the electric force, I obeyed Coulomb's law. After creating the model, I ended up with this photo, which shows the tape on top experiencing two forces that are equal in magnitude but opposite in direction. As shown, the electric force counteracts gravity, leading to the tape on top floating, just as it did in real life. The two counteracting forces leads to flotation because of Newton's second law, which says F equals ma. Since the net force is zero, the acceleration will also be zero. The model found the same charge required as in my observations, 5.4261 times 10 to the negative ninth coulombs. The same assumptions made during the experiment continued into the model, with it not having air resistance, it treating the tapes as point charges, it saying both charges are equal, and it using the possibly erroneous R value. And now to answer some thought-provoking questions. If electrons had positive charge and protons had a negative charge, then not much would change about the experiment. The pen would now be positively charged, but would still attract the now negatively charged tape. The tape would still be repelled by other similarly charged tapes, leading to it floating. However, the final charge would be of opposite sign to the one found. For the second question, it is important to handle the charged tapes as little as possible to prevent grounding the charge and reducing or negating the effects it has on other charged objects. I had a good time doing this lab. I loved fooling with the charged tape and seeing it float. I also liked this lab because it helped me come to a better understanding of Coulomb's law in the real world. Thanks for watching.